Those who have joined the class of finite element method may give their attendance in the chat box. I repeat, those who have joined the class of finite element method may give their attendance in the chat box. Can anyone please respond whether my slides are visible or not?
Visible, sir.
Okay, thank you. So before starting today's class, so today why I am taking this class during this time period is that since I was having invigilation duty from 2 to 4 p.m. so I could not take the class. So in order to compensate that class, I am taking this class at from 7 to 8 p.m. So before starting the class, let me give you a brief recap of what we have did in the last class. If you remember, in the last class, we have taken this problem, and basically, in this problem, it has been told to you that you need to compute different stresses developed in each and every element. So we divided the entire problem into three elements, and then by stiffness method we found out finally the stresses developed in each of the element for this problem. So today we will be solving similar type of problem but with little bit modification. What is that modification? That we have to understand in today's problem. So let us solve the problem. Read the problem. What the problem tells you. Okay, somebody is joining. Just wait for a minute. Okay. So just read the problem. The problem is a bar ABC shown in the figure is subjected to a load of 60 kilonewton at B with a clearance of 1.5 millimeter. Below the section at C, area of AB is 150 millimeter square and length is 1.5 meter. Area of BC is 240 millimeter square and length is 3 meter. Compute stresses in AB and BC of the bar using direct stiffness method of FEM. Take modulus of elasticity E equal to 200 gigapascal. That means what things are given in the problem? In the problem, a bar is given to you. A, B, C is a bar. It is nothing but a composite bar in which AB that is having a length of AB is having a length of 1.5 meter and BC is having a length of 3 meter. End A is fixed and there is a clearance between the end C and the lower fixed end, and that clearance value is how much? That clearance value is 1.5 mm. By the help of direct stiffness method of FEM, we need to compute what will be the stress in the bar AB and what will be the stress in the bar BC. Also in the problem, it has been given that the cross-sectional area of bar AB is how much? It is 150 mm square and cross-sectional area of bar BC is how much? It is 240 square. Also, in the problem, it has been told to you that the for the bar AB at point B, load acting is how much? 60 kilonewton in tensile nature. That means the bar AB will elongate due to this 60 kilonewton. Is the question clear to all of you? Any doubt is there in the question? Any doubt in understanding the question?
No, sir.
Okay. So, can you tell me the difference between the problem which we are solving today and the problem which we have solved in the last class? I am showing you the figure. This is the problem which we have discussed in the last class, and in today's class, we are solving this particular problem. Can you tell me what is the difference between this problem and the last problem? See clearly, observe clearly the difference. This is the figure of the last problem which we have discussed, and in today's class we are discussing this problem. There is a difference in between both the two problems. Can you guess what is that difference?
Sir, I think it is all about the clearance length
Yes,
you're
yes,
talking
very
about.
good. If you see in the last case, in the last problem which we have discussed in the last class, fine. The other end of the bar is free. There is no fixed end. That is the number one difference. And second difference is there is no clear since the bar is not fixed at end D. Fine. So there is no story of clearance in this problem. But
Yes,
in
sir.
the
There is
current
no clearance.
problem which we are solving, if you see the current problem which we are solving, the lower portion of the bar is fixed at a certain distance. So, and that distance is how much? That distance is 1.5 mm. That means I can say that when the end C of the bar BC is equal to 1.5 mm, then this end C will touch this support, yes or no? When the end C of the vertical bar VC, fine, if the deflection of nodal point C for the vertical bar BC is equal to 1.5 mm, then only this vertical bar BC will touch this support, yes or no?
Yes, sir. Yes, sir.
Fine. That
Both is right.
means that means I can take the nodal displacement of nodal point C equal to 1.5 mm for equilibrium condition so that this bar will touch this support, yes or no? That means I can say that the maximum possible displacement of this vertical bar BC at node C is how much? 1.5 mm. It cannot be more than 1.5 mm. It will be either less than 1.5 mm. If it is less than 1.5 mm, then the nodal point C will not touch the fixed end. But if the displacement of node point C is equal to 1.5 mm, then only it will touch. That means I can say that maximum possible displacement of the vertical bar BC at node C is equal to 1.5 mm. Yes or no?
Yes, sir.
Yes, sir.
Fine.
Yes, sir.
So this is the difference. This is the difference which you should keep in mind. Fine. When I am solving such kind of problems. Fine. So this difference was not there in the previous problem that we were solving. Remaining process is same, only you have to understand this difference. Fine. So now let us solve this problem. So if you see in this problem, nowhere it has been told to you that how many elements you have to take in order to solve this problem. Is it given in the problem? क्या कहीं पे क्वेश्चन में दिया हुआ है कि भाई इस प्रॉब्लम को आप 10 एलिमेंट में तोड़ के सॉल्व करो या 6 एलिमेंट में तोड़ के सॉल्व करो? कहीं पे दिया
नहीं
हुआ
सर,
है?
नहीं दिया हुआ।
नहीं दिया हुआ है. Fine. If it is not given to you, then it is your wish. You can solve this problem by dividing the entire geometry into 3 elements, by dividing the entire geometry into 4 elements, by dividing the entire geometry into 2 elements. But if you take, because we know that in FEM, if we increase the number of elements, my solution is much more accurate to the
Exactly.
original solution value. Fine. So what I am doing is, in this problem, I am solving by considering 4 finite elements. How I can consider? I know that AB, length of AB is how much? It is 1.5 meter. Fine. I am dividing this AB into 2 parts. Then this is element number 1. It is element number 2. I am dividing AB into 2 equal parts. Similarly, I am having one more portion, that is BC of this problem. Again, if I divide portion BC into 2 equal parts, I know that the length of BC is 3 meter. Again, if I divide this BC into 2 equal parts, then definitely this will be my element 3 and this will be my element 4. Is it clear how I am dividing the entire problem into 4 elements? Any doubts?
No sir, no sir.
Other people please respond whether any doubt is there or not.
No, sir. No, sir.
Okay. Similarly, you can solve the same problem by dividing the entire geometry into 2 parts. So if you take 2 finite elements, can you tell me what are those 2 finite elements? Say that, suppose I want to solve this problem by dividing the entire geometry into 2 finite elements. So can you tell me what are those 2 finite elements?
The upper portion and the lower portion.
Yes, that means I can say that my vertical bar AB will be element number 1 and my vertical bar BC will be element number 2. Yes or no?
Yes, sir. AB and BC.
Fine.
Right.
Okay, fine. But I am not going for 2 element. Why? Because definitely, if you solve the entire geometry by dividing into 2 elements, you will get some solution value. But those solution value will be less accurate with the exact solution value. Fine. So that's why I am dividing the entire geometry into 4 number of equal elements. So if I divide the vertical bar AB into 2 equal element, can you tell me what will be the length of each element? It will be 1.5 divided by 2. Each length of the element will be 1.5 divided by 2. That means how much? That means 0.75. That means,
0.75.
yes, that means this is my 0.75. Length of element number 1 is 0.75. Length of element number 2 is again 0.75. Similarly, if I am dividing this vertical bar BC again into 2 equal element and I know that the entire length of BC is 3 meter, can you tell me the individual length of element number 3 and 4?
Sir, 1.5, 1.5.
Yes, very good. So element number 3 is of length 1.5 meter and element number 4 is of length 1.5
1.5.
meter. So I got the length of 4 different elements. Is it clear? Any doubt so far?
नहीं सर, क्लियर है, क्लियर है।
Okay. So now next step is what? See, I have divided the entire problem into 4 elements. This is element number 1, element number 2, element number 3, element number 4. That means this will be my node 1. This will be my node 2. Then this will be my node 3. This will be my node 4. And this will be my node 5. So in altogether there will be 5 nodes. I have told you that number of node will be equal to number of element plus 1. Since number of element in this problem is 4, so number of node is 4 plus 1 5. Is it clear to all of you? Any doubt?
No, sir.
Any doubt in number of nodes? Other people please respond whether any doubt is there or not in number of nodes.
No, sir.
Okay, fine. Thank you. So I have divided the entire geometry into 4 finite elements having nodes 1, 2, 3, 4, 5. So let us assume that due to this 60 kilonewton downward vertical force, each node will deflect or each node will displace. Let us assume that the displacement of each and every node is denoted by symbol U. So for node 1, vertical downward displacement, because by looking at this problem, I can see that every node can displace in vertical direction, that too in downward direction. So for node 1, vertical displacement is U1. For node 2, vertical displacement is U2. Node 3, vertical displacement U3. For node 4, vertical displacement U4. For node 5, vertical displacement is U5. Is it clear so far? Any doubt?
No, sir. It's okay.
And it is having a length of 0.75 meter, first element, second element 0.75 meter, third element 1.5 meter, fourth element 1.5 meter. Fine. Next step is what? If you remember the last problem, what we did? Next step is we have to define element attribute table. That means what is the length of every individual element, what is the area of every individual element, what is the value of stiffness for each and every element, what is the value of modulus of elasticity for each and every element. So we are having total 4 elements. So this is element 1, 2, 3, 4. Next is connectivity of element. That means how the element is connected in between nodes. I can see that element 1 is connected through node 1 and 2. This is element 1 connected through node 1 and 2. Element 2 is connected through node 2 and 3. See, element 2 is connected through node 2 and 3. Similarly, element 3 is connected through node 3 and 4. And element 4 is connected through node 4 and 5. And we have already computed the individual length of each element. For element number 1, it is 0.75 meter. Element number 2, 0.75 meter. Element number 3, 1.5 meter. Element number 4, 1.5 meter. Is it clear? Any doubt so far? Hello.
No, sir. No, sir.
Okay. And
Clear
similarly,
as clear.
area is also given to you. If you see in the problem, it has been told to you that AB, area of AB is 150 mm square. Since I have divided AB into two elements, that is element number 1 and element number 2. So for element number 1 as well as for element number 2, area will be 150 millimeter square. Similarly, I have divided BC into element number 3 and element number 4, and since the entire area of BC is 240 millimeter square, so element 3 as well as element 4 is also having area equal to 240 millimeter square. Is it clear? Any doubt?
No, sir.
Okay. So these are the area. I have converted millimeter square into meter square. So I have multiplied it with 10 to the power minus 6, because we know that 1 millimeter is 10 to the power minus 3 meters. So into 10 to the power minus 3. So this is the area of each and every element in meter square. Similarly, I can see from the question that the entire bar is made up of one material whose modulus of elasticity is given to you, which is how much? 200 gigapascal. That means each element is having a modulus of elasticity of 200 gigapascal. That is 200 into 10 to the power 9 Newton per mm square.
Sir,
Okay,
MM or meter?
and sorry, Newton per meter square. Sorry, 200 gigapascal means 200 into 10 to the power 9 Newton per meter square. Okay, and next and the last step is what? Stiffness value of each and every element. I know that stiffness is given by the expression E into A by L. So for element number 1, E is this value. E is your this value. For element number 1, A is this value. For element number 1, L is this value. Put in this expression, you will get the value of stiffness. And since element 1 and 2 are both identical, stiffness will be same. Similarly, element 3 and element 4 are both identical. So value
Thickness will be
of
same.
the 3 and 4 will also be same. If I talk
Hmm.
about element number 3, well, E is how much? E is this value. A is how much? A means area A3. This is your area A3. And L is how much? L is this. So the stiffness for element 3 and 4 is coming out to be 3.2 into 10 to the power 7 Newton per meter. And for element 1 and 2, it is coming out to be 4 into 10 to the power 7 Newton per
3.7.
meter. With this, the element attribute table is completed. Any doubt in this element attribute table?
No, sir. No, sir.
Okay. Other people, please respond whether it is clear or not.
Yes, sir, clear.
Okay, okay. Krishanu, is it clear?
Yes, sir.
Hello?
Yes, sir.
Okay, next. Next is what? We know that now we have to find out the local stiffness matrix for each element. Since 4 elements are there, so I will get 4 different local stiffness matrix. After that, what I will do? I will assemble all the 4 local stiffness matrix to get the global stiffness matrix for the entire problem. So first of all, let us find out for each and every element what is the local stiffness matrix. For element number 1, local stiffness matrix is K1, and we also know that the local stiffness matrix is given by which relation? It is given by K is equal to E into A by L matrix. Fine. And what will be the size of the matrix? Size of the matrix depend upon the number of nodes. I can see that element 1 is connected between node 1 and node 2. So only 2 nodes are present in element number 1. So size of this stiffness matrix will be a 2 cross 2 matrix. That means the first row represent node 1, second row node 2, first column node 1, second column node 2, and inside the matrix I know that the values are 1 minus 1 minus 1 1. Now for element 1 this is K1 E into area A1, length of the element L1. Fine. We have already found out for element number 1, that is EA by L1, that is how much? It is 4 into 10 to the power 7. So I can write 4 into 10 to the power 7, 1 minus 1 minus 1 1. Now I can multiply 4 inside the matrix. If I multiply, the final local stiffness matrix for element number 1 becomes 10 to the power 7, 2 cross 2 matrix, 4 minus 4 minus 4, 4. First row represent node 1, second row represent node 2, first column represent node 1, second column represent node 2. Let it be equation number A. Is it clear to
ये
all
वो
of you?
पहला वाला प्रॉब्लम की तरह ही है.
Yes, एकदम पहले वाले प्रॉब्लम की तरह ही है. Any doubts?
No, sir.
No, sir. No, sir. समझ में
Okay.
आया.
Similarly, I will find out the local stiffness matrix for element 2, 3 and 4. So now you will tell me. Okay. You will tell me tell me that what is the value of element stiffness matrix for element number 2. I know that for element number 2 this will become K2, this will become area A2, this will become L2. What will be the size
L2.
of the matrix? Size of the matrix depend upon the number of node present in that element. Element 2 comprises of only two nodes, that is node 2 and node 3. That means again the size of the matrix will be a 2 cross 2 matrix, but in this case your first row is nothing but node 2, second row is nothing but node 3, first column is nothing but node 2, and second column is nothing but node 3. E into A2 by L2 we have already calculated, that is 4 into 10 to the power 7. Fine, into this matrix again I can multiply 4 inside this matrix. Then the final matrix becomes K2 equal to 10 to the power 7, 2 cross 2 matrix, 4 minus 4 minus 4 4, equation B. Is it clear? Any doubt?
No, sir.
Okay. So similarly for third element, I know what will be the element stiffness matrix or local stiffness matrix, that is K3 equal to E A3 by L3. Again I can see that element 3 is connected between node 3 and node 4. So the size of the matrix again it will be a 2 cross 2 matrix, but in this case the first row will be node 3, second row will be node 4, first column will be node 3, second column will be node 4, and the elements are 1 minus 1 minus 1 1. So E into A3 by L3 is how much? It is nothing but 3.2 into 10 to the power 7. Then 3.2 you can multiply inside the matrix. Then the final matrix becomes this matrix. That is equation C. K3 is equal to 10 to the power 7, 2 cross 2 matrix, 3.2 minus 3.2 minus 3.2 3.2, and for the fourth element also the matrix will be exactly identical, only what will change, only the numbering will change. I know that element 4 is connected between node 4 and node 5, so the first row and first column becomes 4, second row and second column becomes 5, which is my equation number D. Is it clear to all of you? A, B, C, and D. Any doubt in these equations?
No, sir.
No, sir.
Okay.
No, sir.
Other people, please respond. Uddesh, any doubt?
Yes, sir. Clear है.
Okay. Suvarno, it is clear to you? Arko, is it clear? Hello, Arko Gupta, is it clear? Okay, if you are not responding, I will assume that it is clear to you. Okay. Next step is what? Next step is I need to assemble all the element stiffness matrix to get a global stiffness matrix. This global stiffness matrix is one single stiffness matrix for the entire problem. Fine. That means what I will do, I will add A plus B plus C plus D. And what will be the size of this global stiffness matrix? Can you please tell me? I have told you in the last class. What will be the size of the global stiffness matrix? Tell me.
Sir, 5 by 5.
5 by 5. How you can say that it is 5 by 5? How you came to know it is 5 by 5? How
Sir,
you
the
came to
number of nodes I have.
Yes, yes. Always remember when I am solving the problem by direct stiffness method, fine, the size of the global stiffness matrix is equal to the total number of node present in the problem. If you have solved this problem by taking two elements, then your size of the global stiffness matrix will be 3 cross 3, because for two elements 3 nodes are there. Since we have taken 4 elements, Total node is 5. So the size of the global stiffness matrix will be 5 cross 5 matrix. Each row represent corresponding nodes. For that means row 1 and column 1 is nothing but node 1. Row 2 and column 2 is nothing but node 2. Row 3 and column 3 is nothing but node 3, and so on. Is it clear? Any doubts?
Yes, sir. Clear.
No, sir, clear है.
Okay, so next what I need to do, I need to assemble these things. That means if I talk about this particular value, this how I will get, I have to see one first row and first column. That will be my this particular value from A, B, C, and D. So from A, 1 is 4. From equation B, there is no 1. From equation C, no 1. From equation D, no 1. That means this value is 4. Similarly, if I want to get this value, which value? First row and second column. That means this value. Again, I have to find out from A. First row and second column is how much? -4. Equation number B, not present. Equation number C, not present. Equation number D, not present. That means this value is -4. Next is I need to get which value? I need to get this particular value. This particular value is first row, third column. First row and third column. So let us find out from equation number A. First row is there, but there is no third column. In equation number B, third column and third row is there, but there is no first row. And in equation number C, again first row is not there. Equation number D, first row is not there. That means in all the equations D, C, B and A, first row and third column is not present. If that is not present, then by which value I will substitute? I will substitute it by 0. Is it clear? Hello?
Yes, sir.
Yes, sir.
Similarly, if this first, similarly, if I want to find out this particular value, this is what? This is my first row and fourth column. If it is present in equation A, B, C, and D, then you will write. If it is not present, then it will be 0. So if you do like this for the entire 5 rows and 5 columns, you will get this global stiffness matrix. Fine. So let us check this particular value. This particular value is what? It is my second row and second column. So from equation A, second row and second column is how much? 4. Then from equation number B, second row and second column is present, again 4. So it will be 4 plus this 4. Equation number C not present. Equation number D not present. So the value becomes 4 plus 4. Are you getting my point?
Yes, sir.
Similarly, if I want to find out, say, this particular value. Say this particular value. This is what? This is my fourth row and fourth column. Let us find out. Equation number A, fourth row, fourth column, not present. Equation number B, fourth row, fourth column, not present. Equation number C, fourth row, fourth column, present. Value is 3.2. Equation number D, fourth row, fourth column is present. Value is 3.2. So the resulting, this fourth row and fourth column becomes 3.2 plus 3.2. That is 6.4. And so on. So now I think I have made myself clear how to get this stiffness matrix or how to write this stiffness matrix. Is it clear to all of you?
Yes, sir.
Okay. Other people please respond whether it is clear or not.
Yes, sir. Yes, sir.
Clear, clear.
Clear. Okay. So likewise, we will find or we will compute this global stiffness matrix, and this 10 to the power -7 is out of this matrix. We have taken it common. Fine. So if I solve this matrix, that means if I add these values, 4 plus 4 becomes 8, 4 plus 3.2 becomes 7.2, 3.2 plus 3.2 becomes 6.4. So this equation E will yield you the global stiffness matrix. Is it clear? Any doubt till equation E?
No, sir.
Okay. Other people, please respond whether everything is clear or not.
Yes, sir, clear.
Okay. Next step is what? After finding out the global stiffness matrix, I need to write the governing algebraic equation for the problem. Since the governing algebraic equation is which equation? That is F is equal to K into X or K into U. That is my
Yes,
governing
K into
algebraic
equal to X.
equation. Yes, that is restoring force equation. F is equal to K into X. But if I solve the same problem by Rayleigh-Ritz method or by Galerkin method, then I have to use the governing differential equation. Are you getting my point? Hello.
Can you repeat this thing in 1 second?
Yes, since I am using direct stiffness method, I have told these things earlier also. In direct stiffness method, the governing equation is nothing but the restoring force equation that we get from a spring, that is F is equal to minus kx. Normally we exclude the minus term, so F is equal to K into X. F is what? F is the force acting on the element, K is the stiffness matrix of the element, and X is what? X is the displacement of the node. So I can write the governing algebraic equation as F is equal to K into U. What is K? K is nothing but the global stiffness matrix. What is U? U is nothing but global displacement vector matrix. And since 5 nodes are present, so the global displacement vector matrix will be U1. It is a column matrix. U2, U3, U4, U5, 5 row and 1 column. That is this matrix. And what is this F? F is your global force vector matrix. Global force vector matrix. Since there are total 5 nodes, so let us assume that each node is subjected to some forces. Node 1 is subjected to force F1, node 2 is subjected to force F2, likewise node 5 is subjected to force F5. So again it will be a column matrix, that is 5 row and 1 column, and it is given by F1, F2, F3, F4, F5, which is equal to U1, U2, U3, U4, U5 into this global stiffness matrix. So this is the matrix form of the governing algebraic equation. Is it clear to all of you?
Sir, I
Any
have a
doubts so
question.
far? Yes.
Sir, why there is no minus sign in that equation F is equal to minus K into U?
Yes, we are not, see, minus sign indicates that when you release the spring will come back to its original position in the opposite direction. So just for analysis purpose, we are not taking the minus sign. That minus sign just give you just indicates that the spring will return back to its initial position by the
Okay, sir.
same amount of force, which you have applied on the spring to deflect that spring. Is it clear?
Yes, sir, clear.
Okay. So other people, please respond whether this matrix equation is clear to you or not. Hello. Please respond whether this matrix equation is clear or not.
Yes, sir.
Sir,
Okay,
clear.
so I can see that this first row. Wait, yes, this first row is what? First row is nothing but first node. First column is first node. Second row is second node. Second column is second node, and so on. So now next step is what? Next step is I have to evaluate the boundary conditions of the problem. So by looking at the problem, can you tell me which boundary condition is given to you? If I talk about displacement, so according to displacement, which boundary condition is given to you in the problem? If I talk about displacement, then which boundary condition is given to you in the problem? Hello.
सर समझ में नहीं आ रहा.
I think Pradyut, you have missed many of my classes, so that's why I think you cannot you can't understand. Okay, I'll make you understand. I am asking from Krishanu and Uddesh and Orko because they are regularly attending my classes. So can you please tell me which boundary condition is given to me in terms of displacement? I can see
At A, the
displacement
displacement
will
is
be
0.
zero, but
Yes,
A is what? A is my node 1? Yes or no? A is nothing but my node 1. So I have told you earlier that if anything is fixed, that means that particular node cannot move in any direction. Fine. So displacement U1 is 0. Is it clear? Is it clear?
Yes, sir.
Fine. Okay. So this I got one more boundary condition I am having. That is, I can see that
sir, is
the
equal to 100.
maximum possible displacement of node 5. And node 5 is which one?
Sir, 1.5 means
Yes. This is my node 5. This is my node number 5. Maximum possible displacement of node 5 is 1.5 meter. It cannot go beyond 1.5 meter because if it will go beyond 1.5 meter, then this node 5 location of node 5 will be outside this fixed region, which is not possible. So that means U5 is also given to me. That is 1.5 meter. Is it clear to all of you?
yes, sir. Yes, sir.
Other people, please respond whether it is clear or not.
सर एक बार फिर से रिपीट कीजिए सर.
Okay, I know that this node 1 is fixed. If node 1 is fixed, that means this node 1 cannot displace anywhere. That means displacement of node 1 is 0. That means U1 is 0. Fine, this is node 1. This is my node 2. This is my node 3. Then this is my node 4. And this one is my node 5. One more boundary condition is given to you, that is U5. This node U5 maximum value is how much? It is 1.5 mm. It cannot go beyond 1.5 mm. If it is going beyond 1.5 mm, then this particular end will come out of this fixed end. Is it possible? It is not possible. Either it should be equal to 1.5 mm or it should be lesser than 1.5 mm. But the
Yes, sir.
maximum possible displacement of this node 5 is 1.5 mm. That means when you put U5 equal to 1.5 mm, this node will be at exactly at this point. Is it clear?
Yes, sir.
Clear.
Okay, so that is why U5 is 1.5 mm. This boundary condition is given to you. This is the difference from the last problem. The last problem which we have discussed, this condition was not given to you. So this is the difference. Okay, just wait. So U5 is how much? U5 is my, yes, U5 is 1.5 mm. One more boundary condition is given to you in terms of force. Now, if I talk about force boundary condition, can you tell me which force value is given to you? This is node 1, node 2, node 3, node 4, node 5. I can see that at node 3, force acting is how much? Force acting is 60 kilonewton. If I assume this to be tensile, that means this force to be tensile, definitely this force will be compressive. So if I take tensile force as positive force, I have to take compressive force as negative force. That means F3. F3 is what? F3 is force acting at node 3, and that is how much? That is 60 kilonewton. Is it clear? It is also given to you in the problem. Any doubt? This
No, sir. No.
F3 is
No, sir, clear.
F3 is 60 kilonewton. Clear? Okay. So what I will do is in the next step, just wait. Yes. So in this step, what I will do, I will in the next step, I will evaluate, I will substitute u1 0, I will substitute u5 by 1.5 mm, and I will substitute f3 by 60 kilonewton. Okay, so let us substitute. This global stiffness matrix is same as it is into, see, u1 is 0, u2, u3, u4. This I have to find out. Fine, I don't know. U5 is how much? 1.5 mm. So I am converting it into meter because my value, because my this particular matrix, stiffness matrix value is in Newton per meter. So it is 0.0015 meter equal to, this is my force matrix. Now, see, F3 is given in the problem. That is how much? 60 kilonewton. 60 kilonewton. Fine. Remaining force value is not given in the problem. That means at node 1, no nodal force is acting. At node 1, no nodal force is acting. At node 2, no nodal force is acting. At node 3, nodal force is 60 kilonewton. At node 4, no nodal force is acting. At node 5, again, no nodal force is acting. If no nodal forces are acting from outside in the problem, I will assume it to be 0. This is also one, this is nothing but the Gauss elimination method. This is also one form of Gauss elimination method. So I will evaluate F1, F2, F4, F5 by 0. It will not be 0, it will be having some values, but I will not be able to solve this resulting matrix equation if I not put it 0. So I will put F1, F2, F3 and F5 0. Only this F3, since it is given in the problem externally, which is 60 kilonewton, so I will put only this F3 value. Is it clear? 60 kilonewton, that is 60 into 10 to the power 3 Newton. 10 to the power 3 I have taken out of this matrix. Any doubt so far in this equation? This, which equation? This particular equation. Is it clear?
Yes, sir,
Yes,
clear.
sir.
Okay, okay. Krishanu, is it clear?
हाँ सर हाँ
Okay, now, see, in this particular expression, unknown is u2, unknown is u3, unknown is u4. But if you see in the right hand side, this value is 0, this value is 0, this f4 is 0, f5 is 0, only you are having f3 value. So if you see, if you write if you solve row 1, that is multiplication of this matrix, that is this row into this column is equal to this value, it will be how much? It will be 4 into 0, 0 minus 4 into u2 minus 4 into u2, again 0 into u3, 0 into u4, 0 into 0.0015, 0, which is equal to 0. That means u2 is 0, which is not possible. So that means if you consider row 1, row 2, row row 4, row 5. If you write the equation, fine, you will not be able to solve because right hand side value is already 0. Can you get the value of u2, u3 and u4? Can I get the value of u2, u3 and u4 by this process? Hello?
Yes.
No, sir. No, sir.
I will never be able to get
No,
the
no,
I
no.
have
value
to
of
eliminate this.
u2, u3 and u4 by this process. But if I see the problem, u2 is not fixed, u3 is not fixed, u4 is not fixed, u5 is obviously 1.5 mm. So there will be some definite value of u2, u3 and u4. But if I see this matrix equation, I will not be able to get the value of u2, u3 and u4. I will get u2 0, u3 0, u4 0, which is not at all possible. So in order to make it possible, what I am doing is, see, okay. If you consider first row, this first row is not having any effect of this u5 value. If you consider, for that means if you multiply first row with first column, fine, 0 into this value, which is equal to 0. If you multiply second row with second column, you will get second equation. Again, see this 0 into this u5, again it is 0. If you multiply third row again with this column, again you see this 0 into 0.0015. Fine. But if you consider fourth row, that means if you consider the fourth row, that is which row? This fourth row into this column. Will you get 0? When you multiply this value with this value, will you get 0? Will you get 0? Hello? Hello?
No, sir.
I will not get 0. That means if you
So we have to
solve,
eliminate
yes,
the
yes, that
row
means
and column.
if you solve for first row, since when you multiply this with u5, fine, it is 0. So this value will never change. When you go for second row, also since this 0 into 0.0015, this value will never change. Similarly, for third row, also this value will never change. But since when you are writing the matrix equation for the fourth row, that means this fourth row into this column, when you are multiplying, you are getting a definite value. When you are multiplying, this 0 into 0 is 0, 0 into u2 is 0, minus 3.2 times of u3 plus 6.4 times of u4 minus 3.2 into 0.0015. That means you are getting some value. If you are getting some value, then this right hand side expression of f4 can never be 0. This can never be 0. Fine, it will have some definite value. So for that, what I will do is I will consider the fourth, I will write the matrix equation for the fourth row. I will write the matrix equation for the fourth row. So if I write the matrix equation for the fourth row, I can write that 0 into 0 is 0. 0 into u2 is 0. That means this fourth row into this column. So 0 into 0 is 0 plus 0 into u2 is 0 minus 3.2 into u3 is, see, minus 3.2 u3 plus 6.4 into u4, see, 6.4 u4 plus of minus, plus minus minus 3.2 into 0.0015 into 10 to the power 7, fine, equal to 0. If you solve this expression, Fine. And if you take the constant value, which is means in which no in which no variable is present towards the right hand side, then the final equation becomes 10 to the power 7 times of minus 3.2 times of u3 plus 6.4 times of u4 equal to 48,000. This is the original equation if you consider row 4 in matrix form. Is it clear? Is it clear?
Yes, sir.
Other people please respond. That
Yes,
means
sir.
I can now say that this is RHS and this is nothing but F4 since we are writing this equation for the fourth row. So this fourth F4 is nothing but 48 kilonewton. So this F4 is nothing but 48 kilonewton. Fine. So again, if I write so now I got one more boundary. I got one more value. Earlier I got what? Earlier I got U10, U50, F3, 60 kilonewton. Now I got F4 how much? F4 equal to 48 kilonewton. 48,000, that means 48 kilonewton. Now, if I substitute this F4, if I substitute this F4 over here, U1 is already 0, U5 is 0.0015 and F3 is 60 into 10 to the power 3. And now if I solve this matrix equation, I can solve. Now I have to use Gauss elimination method. Gauss elimination method says that if RHS is 0, and this RHS is corresponding to this first row, this is 0, that means you can eliminate first column also. Similarly, this F2 is also 0, which is nothing but this second row, so you can eliminate second row as well as second column. Fine. So the resulting matrix becomes what? Sorry, not this second row. Sorry. Erase. So this F2 will not be equal to 0 because if you see, yes, this will be F2. Fine. Due to this 60 kilonewton, if the vertical bar AB is displacing in downward direction, definitely there will be some nodal force F2, which will be 0. F5 will be 0 because maximum deflection of nodal point number 5 is U5, which is equal to 1.5 mm. Since if U5 is 1.5 mm, that means if U5 is 1.5 mm, that means this end, this nodal point 5 is exactly touching the fixed end. And if it is exactly touching the fixed end, again at fixed end, there will be no force. How? Because if you draw the free body diagram, fine. If you draw the free body diagram of bar BC at point C, the force is acting along this direction. Fine. And similarly, this fixed support will give back the force to node 5 in this direction. Ultimately, the effect is 0. So this F5 is 0. Is it clear? Is it clear?
Yes,
Yes,
sir.
sir. Clear.
Other people please respond. It is clear or not? So this F5 is 0. So this F5 is this is only 0 when U5 is 1.5 mm. If U5 is lesser than 1.5 mm, this will not be 0. आ रहा है समझ में मैं क्या बोलना चाह रहा हूँ?
Yes, sir. Understand.
बाकी लोग को
हाँ
समझ
सर,
में आ रहा है?
हाँ सर
ओके ठीक है. So what is the case now? The case is F1 is 0, so I can eliminate the first row and first column, and Since F5 is 0, I can eliminate fifth row and fifth column. This is Gauss elimination method. So I am left with second row, second column, third row, third column, fourth row, fourth column. So it will be a 3 cross 3 matrix. That means this matrix. And it will be equal to U2, U3, U4, which is equal to this 0, 60, 48. That means this matrix. Is it clear?
Yes, sir. Clear.
Other people, please respond whether it is clear or not.
Yes, sir, clear.
Fine. Now, please tell me, by looking at this matrix equation, can I get now the value of U2, U3 and U4? If I solve this matrix equations, now can I get the value of U2, U3 and U4? Yes, I can get.
Yes, yes.
Now
Yes.
I can get the value of U2, U3 and U4. I am having three unknowns. Yes, I am having three unknowns, U2, U3 and U4, and I am having three equations. So if you solve for second row, it will be this row into this column equal to this value. For third row, multiplication of this third row into this column will be this value. Similarly, multiplication of fourth row into this column will be this value. Solve these three equations by the help of calculator. You will get the unknown nodal displacement value U2 as 1.17 mm, U3 as 2.33 mm, U4 as 1.92 mm. Is it clear? Any doubt?
Yes, sir. By solving this matrix, we will get this
Yes,
answer.
वो आप
U2,
कर
U3.
सकते हैं, आप वो करते आ रहे हो, सॉल्व बचपन से करते आ रहे हो, तो वो मैं नहीं करा रहा हूँ यहाँ पे, ठीक है? इज इट क्लियर?
Yes,
Yes,
sir.
sir.
Clear.
तो समझ में आ रहा है लास्ट प्रॉब्लम में और इस प्रॉब्लम में क्या डिफरेंस है? लास्ट प्रॉब्लम इजीली सॉल्व हो गया था क्योंकि ये कंडीशन ही नहीं दिया हुआ था. ये जो कंडीशन था कि इस प्रॉब्लम में इतना स्पेस ओपन है, ये कंडीशन था ही नहीं लास्ट केस में, इसलिए इजी था प्रॉब्लम. हम मैट्रिक्स इक्वेशन को सॉल्व करके इजीली निकाल सकते थे. अब यहाँ पे ड्यू टू दिस गैप आई एम डूइंग दीज थिंग्स. आ रहा है समझ में?
हाँ सर इसमें कंडीशन दिया हुआ है.
Okay. So we got the value of U2, U3 and U4. Now since I need to find out what? I need to find out the element stress value. So I know that stress in element is given by which equation? This equation, that is sigma element is equal to E into, I know that by Hooke's law, stress is proportional to strain. So stress is equal to modulus of elasticity into strain. So stress
Yes.
is equal to E into strain. And again, I know that in FEM, strain is given by the strain displacement matrix B into this nodal displacement vector matrix transpose for a particular element. So that is sigma of any element is equal to E into strain displacement matrix into, this is what? This is nodal displacement vector matrix transpose of that matrix for a particular element. Since I am talking about element number 1, I am talking about element number 1. So sigma 1 is equal to E. Again, I know that this strain displacement matrix is nothing but it is a 1 cross 2 matrix. It is a 1 cross 2 matrix and 1 row and 2 column and is given by minus 1 upon LE, 1 upon LE. What is LE? LE is the length of the element, and I know that length of first element is how much? It is 0.75 meter. It is 0.75 meter. So it will be minus 1 upon 0.75, 1 upon 0.75 into, this is what? This is no transpose of nodal displacement vector matrix. And for element number 1, and I know that element number 1 consists of node 1 and node 2. So it is, I can write it as node 1, node 2, transpose. And I know that transpose of a matrix, that means row becomes column, column becomes row. So ultimately the matrix becomes sigma 1 is equal to E minus 1 upon LE, 1 upon LE, column matrix, that is 2 cross 1 matrix, U1, U2. Now E you know 200 into 10 to the power
value
9.
put दूंगा मैं.
Then matrix minus 1 upon LE. LE means length of the first element, that is 0.75. Minus 1 upon 0.75, 1 upon 0.75 into U1 is already 0. U2 just now we have calculated, that is 1.17 into 10 to the power minus 3 meter. Just evaluate it. You will get the value of the stress
Sigma 1.
in the first element. That means when
Similarly
you
for
will
the second also, third also.
Yes, that means when you will multiply this matrix, this is what? This is 1 cross 2 matrix. 1 row and 2 column, and this matrix is what? 2 cross 1 matrix. 2 row and 1 column. That means this 2 and 2 is out. So ultimately the resulting matrix will be a 1 cross 1 matrix. That means 1 row and 1 column. That means minus 1 by 0.75 into 0 plus 1 divided by 0.75 into this value will be this value. Then multiply this value with 200 into 10 to the power 9. You will get the stress present in the first element, and that is coming out to be how much? 312 megapascal. In similar manner, you can find out the stress in the second element, and likewise you can find out the stress in the third element as well as stress in the fourth element. But in the problem it has been told to you that you need to compute the stress present in AB and BC. I know that AB comprises of element 1 and element 2. BC comprises of element 3 and element 4. So total stress present in AB is how much? Stress in element number 1 plus stress in element number 2. Total stress present in BC bar is how much? Stress in element number 3 and stress in element number 4. This will
Number 4.
be the final answer. Is it clear? And that value is coming out to be, I will show you. Yes, that value is coming out to be sigma 1 plus sigma 2 is 621 megapascal, and sigma 3 plus sigma 4 is minus triple 1 megapascal. Is it clear?
Total stress are the in AB, sigma 1 plus sigma 2.
Yes. Is it clear? That means
Yes.
bar
Yes.
AB is subjected to tensile stress, and since BC is negative, we can say that bar BC is subjected to compressive stress. Is it clear to all of you? Any doubt in the problem?
No, sir.
No sir, clear है, clear.
Okay. So
सर ये
what I
आने
am
से
doing
कितना
is,
मार्क्स का आएगा? 10 marks.
if it is, if I, it depend upon how many element. If in the exam I tell you that okay, solve this problem by considering the solve this problem by dividing the entire problem into 5 elements, then definitely for 15 marks. But if I give that solve the given problem by dividing the entire problem into 2 parts, definitely it will be of 7 marks. Likewise.
Okay.
But if in the problem nothing has been given to you, see in this problem nothing has been given to you, fine. Then you have to see the marks of the problem. If the marks is 15, definitely you will not go for 2 elements. You have to go for 4
For 4
elements.
elements.
Fine. And if the problem is of 7 marks, and if nothing has been told to you that in how many number of finite elements you need to divide the problem, then definitely you will go for 2 elements accordingly. Fine. So such type of problems are present in the are there in the book which I have given you in the Google Classroom. So just practice it. It is not possible for me to solve each and every problem, but what I am doing is I am just showing you each and every variety. I am showing you one problem I am picking, and I am showing you the different variety. In the next class, I will show you the taper problem. How to solve taper problem by this method. With this, we will complete the sub part of this module. First sub part. Actually, this module contains, there are total 3 sub parts are there in this module. Fine. So with that taper problem, we will be finishing the first sub part. Okay. Hello.
Yes, sir.
Fine. So Monday also I will not be able to take the my regular class. I am having the invigilation duty. Okay, just wait for a minute. Just wait for a minute. I hope all of you have given your attendance because it will be counted. I will count these attendance. Okay. And just wait for a minute. Okay.